Hello. I'm going to do problem 6.52. So the problem says for the circuit below, determine IL0 and VO as 0. Derive the differential equation for IoT for t greater than 0, and solve the differential equation obtaining the split expression for IoT given that from the following equations right there. For t, so we're gonna solve by doing t less than 0, meaning that these R1s that'll be in the equation because it's not part of the circuit, it's not a current. And the capacitor and the inductor is going to be open and closed. So the capacitor is going to be open and the inductor is going to be closed. And it's going to look like this basically. This is the inductor and this is the capacitor. And the capacitor becomes VC as 0 minus. And you're going to solve for that by using voltage divider. You're going to solve VC as 0 for using voltage divider by implementing it. And just the equation going like this. VS R2 by RS plus R2 equals to 12 times 1 over 4 equals 3 volts. And which just means that VC is 0, negative, equals to VC is 0, equals 3 volts. And we're also going to solve for IL0 right here. And it's going to be IL0, infinity, negative, equals to, we're going to use Ohm's law. So it's going to look like this. VS, or RS plus R2. And, sorry, RS is going to be 12 over 4 equals to 3 amps. So it's going to be volts over ohms, 12 volts over 4 ohms. And afterwards, we finish that part, and we move to the next part. It's gonna be look for VO at 0. So we're gonna do t greater than or equal to 0, which the switch is going to look. It's going to go from 1 to 2. So it's gonna look like this, like this. So switch is gonna be like this, and L is gonna be VL plus or minus, and its capacitor is gonna be VC plus or minus. And you're gonna implement here. You're gonna implement KVL in this circuit. And the equation look like this, kind of look like this basically. Negative VC plus VL plus IL R2, 0. And we plug in the numbers that we got from here, from this part to here. So it's gonna look like this. Negative 3 plus VL plus 3 times 1 equals 0. VL at 0 equals to 0. And we're going to use this part right here, this equation I wrote before this part, and to solve it, to solve for to derive the differential equation. So the equation is gonna look like this. It's gonna be VL plus IL R2 equals to VC, and VL becomes L IL prime plus IL R2 equals VC. And afterwards, we're gonna derive the differential equation for IoT, which I did right here. So we're gonna use KCL, and we're gonna have a node here. It's gonna be BC. This is gonna current right here. It's gonna be current right here, and it's gonna be current right here. So this current is gonna be IR1. This current should be IL. This current is gonna be IC. And so this can be the KCL right here, and IC becomes this due to this equation, and IR1 becomes this equation due to being Ohm's law. And afterwards, we plug in VC from that we got from this equation right here to this equations. Afterwards, we simplify the equation furthermore right here. In the next step, we want to have IL double prime alone. So in order to do that, we're going to multiply each part by 1 over LC to each part right here. And oh yeah, I simplified it furthermore right here. so it's to be more organized. And after that, once we simplify it by multiplying 1 over LC to each part, it's going to become like this. Afterwards, we're going to plug each part to this number that was given now in the equation right here. And once we plug everything in, the equation is going to come like this. Okay, now we're going to solve for the equation. We're gonna solve for the circuit if the circuit is critical damp, under damp, or over damp. So in order to determine that, I'm gonna use this part right here, and it's gonna look like this: a over 2 equals to 1.5 over 2 equals to 0.75, and W naught is going to be b squared equals to 0.75 squared equals to 0.86, 0.86. And since A is less than W naught, the equation is underdamped. Since the equation is underdamped, based on the chart right here, you're gonna use this whole part right here by solving these parts in order to get this final equation right here. So it's gonna look like this basically. So it's gonna be IO infinity equals to C over B equals 0 over 0.75, so 0 equals to 0. WD is going to be square root of W naught to the second power minus A to the second power, which will equal to 0.86 to the second power minus 0.75 to the second power, which it will equal to the final answer as 0.42. So that's our WD. For D1, it's going to be IO 0 minus IO infinity. It says IO 0 is 3 and IO infinity is 0, so it's going to be 3 minus 0 is going to be 3. For D2, it's going to be IO prime is 0 plus A IO 0 minus IO infinity. And it will equal to, over WD. And once we plug everything in, for IO infinity, IO prime 0, we're gonna do this. VL 0 equals L IO prime 0. And we're gonna simplify it by doing VL 0 by L and equals to IO prime 0, which is going to be 0 over 2 equal to 0 equals to IL prime as 0. So and once we plug everything in, the answer is going to become 5.3. And finally, we plug everything in to the equation of IoT. It's going to be 3 cosine 0.42 t plus 5.3 sine 0.42 t e to negative 0.75 t. And this is our final equation right here. Thank you for watching.